Okay. Okay. Cool. Um, so come back to here. So now you can answer me. So if any business problem given to you, okay, let me take a small example and then show you. So today what I'm going to do is I'm considering I will consider myself as like a person who is exploring from case study, and then out of this case study I will use the relevant code, and also I will add more and more of our code in the existing one. This is one of the popular one, okay, where you can find in common in many of the online resources. Today I will use the same case study, okay, how I am doing this case study, so that you can also follow, and also you can improve also. I mean, you add your own way of doing, because this data science is always, I consider it as an art. Art means every individual can do it in different way. That is why there are a lot of jobs and there are a lot of opportunities around data science, because everyone can come up with their own way of providing a solution. If someone if one person can provide a solution to all the problem statements, means there will be always less opportunities. But here there are a lot of opportunities. That means everyone can have their own way of solving a problem statement, right? So that is why today I will consider, and I will you can also participate along with me. You can also add your points, add your way, add your understandings, how exactly you thought something is right, something is wrong, all such things. Today is actually fun activity, so that you can actually involve in solving a real time. That is why today I am not coming with any code. You can see I'm not coming with any code. Just will explain you the concept of Naive, and then we'll straight away we together can solve this problem statement. Anyway, I assigned you a task of doing the this one, right? So that today, if you can participate along with me, and it will be really easy to you in solving all the case studies, whatever you are picking up. Okay. Okay. So today, before going to
Did you start the recording?
yes, recording just now I started.
Okay, thanks.
Yeah. So forecasting car quality is the what we really want. So forecasting data set Kaggle, or UCI is also one more platform. UCI, machine learning repository it is. If you go ahead and see, here also very wonderful libraries, sorry, data sets you will get. Wine quality, breast cancer. But this UCI is on, I mean, it is really good if you are researching. Okay, really good if you are doing researching. For example, if you pick one algorithm and pick one data set and really wanted to check all the hyperparameters and all, and really wanted to see and observe the results, then note down and all. If you are interested into healthcare, you can see heart disease is there. Okay, drug and is there, gas sensor related one, social media, geographical, geospatial data. See more data set. Here, if you click here, you can see more popular data sets. These are all popular data sets, more data sets. Banking data set, banking marketing, anything you can see. For example, today, let me know from the audience only. I will ask. I will take. Which domain today shall we explore? If anybody gives me the domain, so that I will consider that domain only.
Yeah, automobile or manufacturing.
Automobile? Okay, fine.
Or manufacturing, yeah.
Okay. Today, let's do one thing. Today, we will consider the automobile. Maybe next algorithm, we can consider another domain. Okay. Is that fine? Maybe aviation. Prajwal is
Sure,
really interested to go for aviation, maybe. Right. Good.
sure.
Then banking one day we can consider banking, and one day maybe e-commerce or any other supply chain, something like that. Okay. Today is automobiles. So we'll go and check, for example, car evaluation. We will check car evaluation. Here you can see it is a multivariate one. That means multiple variables are there. It is for classification. You can see there are 6 features are there. There are total these many instances. It is categorical data is also there. So we can do car evolution was derived from simple hierarchical decision. What exactly, from where exactly they got the data, all you can see. This is automobile, and manufacturing is, I'm not saying manufacturing, maybe it is comes under automobile. It got donated. See, 531 1997. Very, very old data set, but still it's a good one because many people been used here. 1998 paper also got published. So it has no missing values. One good thing is, and you can learn quickly what exactly that the data set is talking about and all. You can get the data set easily using this download button. Once you download it, then we will observe how data set looks like. I will extract this data, sorry, not share. This next option to share, I have to click extract all. Browsing and locating to the file where I'm dealing with sessions. Yeah, it got here. Where is that now? Insurance, no. Car names, here you can see CSV. No, it is not CSV names. It is data file. You can see the extension, it is data file. Then you can open that. You can convert to the CSV. How to get convert is right click. Sometimes this works. Open with. Okay, choose an app. No. Um, okay, no problem. We will try to read the data file also today. We will learn that concept. So here it is a names file. Word file you can use for names file. Here you can see there are some values are being teaching us. You can go through. Buying is very high. Okay, high, medium, low. Okay, someone has joined. Let me in that person. Yeah, Mushraf. Okay. So some other column is there. Maint, maybe maintenance. Door stands for doors. How many doors? Persons. Okay. How many persons? Luggage, boot, and safety. So these are the attributes actually. So if I see these are the attributes, and I would like to check one more thing because I feel it is very small data set and also old data set. Let me check one more thing and let's not also waste time. Automobiles, AUTOM automobile. Click enter. Automobile 1985. So here some filter is also expand all. Yeah, here it is there. Uh, task. Yes, task is classification. Choose the classification one, and instances and Python. Yes, available for Python import. Okay, available for Python import. Thar evolution is the only one I got. Fine. I uncheck it. Then these are the thing. Artificial characters, chess for classification. Subject area. Yes, here I can choose the subject area. Law, physics, social sciences, engineering, computer science. Okay, no problem. We we will go and check in Kaggle itself. Kaggle.datasets. Kaggle.com/datasets will directly take you to the Kaggle datasets. There you can directly ask automobiles. Automobiles cars project dataset. So we will see hotness. Hotness means recent ones. Okay, so all these are a year ago car dataset. Let me open and check how exactly the data. If it is looking nice, then we can have a look. The dataset is like this: first name, last name, country, car brand, and car model, car color, manufacturing year, car type. Okay, but we wanted to use it for classification, right? So then we'll go and check for some other things. Most votes, new, recent ones, 7 hours ago. See, updated a day ago. Vehicle CSV 2 days ago. What is this vehicle CSV? Compact. This is 19 columns are there. Sports car. Yeah, okay. Just 2 more minutes provide me. So with this time, we will check the best one. Electric vehicle population in USA. This is somewhat interesting. Okay. Is there any column for us to predict? The dataset is ideal for analyzing the market penetration, region distribution, and policy evaluation, clean transportation. Okay. So one good news is there is no one so far, uploaded any Jupyter notebook. You can take that initiative. Okay. You can take that initiative. If more number of citations are increasing, definitely, the impact is different. So people will add comments, people will teach you many things. Even I too did not try so far. Maybe we can try. Okay. Because like every time I thought, okay, somebody already did something like that. But here there is no notebook at all. So you can upload. Here you can see no new notebook and you can upload one. Okay. Here also you can write a code itself. Okay. If you are interested, we can upload. It is electric vehicle population in USA. We can read about the data set and then we can see if there is any valuable thing to predict. Simple way also you can do, like don't take that and think that we have to do it in professionally, something like that. Of course professionally, but don't think it in a like a high level and all. Simple way is also fine as of now. We can see which column exactly is there for us to predict. Okay, so we have to search that. I will share this to you in WhatsApp also. Okay, so you can go through that. Very nice. One good thing happened without having any code we got. Fine. If there is no other data set, means we will go with this only. Car data set only we will go. Okay. Fine. I just wanted to try really one good thing. No problem. Let me try it in my free time. Why to waste time here? Fine. Charge my tablet today. Okay. So now we can focus now on into the uh, you know real thing. So now answer me. If there are three columns are there, three columns are there. Column A is number of, let me see, let me show you. A, I will take it as B, I will take it as output. Okay. So I will consider it is 1, 2, THRE3. Okay. 2, 2, 1, THRE3. Okay. Here, yes, no, 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 yes, yes. Output is 12.4, 12.8, 120.5. Okay. So now tell me, I wanted to I wanted to predict my output value. Okay. I wanted to predict my output column. So these are these are the features. Okay. These are the features, and this is output is what my expecting to predict. So which type of machine learning it belongs to? Okay, that is a question. Anybody?
We can use supervised algorithms.
Okay, supervised. Very good. Why?
It has an output label and input data on output label.
Correct. Supervised. In supervised again, which type of algorithms we can use?
So we have like classification and regression algorithms. So
Okay, classification and regression, right? So out of classification and regression, if I take my output column, if I give A and B, for example, A will be 1, it is no, then I wanted to predict the output. So which algorithm I can use? Think. The approach you can think. Meanwhile, I will enter this data. Yeah. Anybody? Yeah. So what is this approach? Like what are the types of algorithms or type of algorithm that we can use to predict this orange one and the red one, or not red, the maybe this sky blue. Okay. So sky blue means which type of algorithms we can use here, and orange means which type of algorithms here. Prajwal is really right. He told one strategy. It is supervised because it is having the columns of both input and output. Very good. And he also
sorry, Ishad, it's Mushraf. It's
okay,
me who
sorry,
said
sorry.
it's
I
supervised.
did not see, sorry. Okay, fine, fine. Okay, Mushraf has said right. So he identified the columns correctly and also output column he also, but now thinking. So which algorithm is used here and which algorithm is used here? Can be used, not used, can be used here, can be used here. So
For the second one, we can use logistic, I think, logistic regression and,
classification simply it is right,
oh, classification. Yeah.
correct. So
Yeah.
inside classification we can use logistic. Very good.
Yeah.
uh, right, Maria? Right, Maria?
Yeah. Maria. Yeah.
Yeah, logistic. Okay, fine. Here for the first one, don't confuse. If your output column is continuously arranged, then it is regression.
Yeah.
Got it? Then it is regression. I will use it here. Then it is regression because it is continuously arranged. Output column is continuously arranged. Continuously arranged. Then I have to go for continuous means regression. If it is, discrete, the output column is discrete, 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 then it is classification. And then you can decide what algorithm, logistic, or we are going to now learn about naive Bayes. It is all secondary, but this is primary. Definitely, this is what the approach in choosing the machine learning algorithms. Okay, it depends on the output column. Is that clear, Mushraf? Now, is that clear? Okay,
Yes, yes.
very good, very good. So this is the way how we can choose the type of algorithms based on the output column. Remember, okay? Now, so now we are dealing all about classification algorithms. Regression we already learned day before yesterday. Yesterday we learned one type of classification algorithm. So now we are going to learn about second type of classification algorithm, that is what? Naive Bayes. What is this naive Bayes? Here, first of all, let us understand what naive Bayes is. Very uh, clear notes I provided here. Easy way you can easily understand and remember it for a long time. Naive Bayes algorithm classifier is a probabilistic machine learning algorithm. It is completely based on probability theorem, and probabilitical results only it will provide. Probability means I already told you, but again I am again revising. Probability here refers to the chance. What can be the chance? The chance actually is what the prediction. Got it? So if 50% chance or 30%, 20%, that value will gives us the chance. Okay, that is what in probability we learned. So here what is the thing that we are going to learn is naive Bayes is a probabilistic machine learning model built on Bayes theorem. Bayes theorem is a very popular in probability. So it has two terms if you observe naive Bayes. Naive because of naive means it is assuming all the features whatever are there in our data set are independent of each other. Are independent of each other. Yesterday I told you the difference between the dependent features and independent features. For example, in this particular data set, this is what dependent because it is depending on A and B, right? Instead of C, I will type it as output. It is depending on, the output is depending on A and B, correct? That is why the output column is always called as independent column. Sorry. Dependent column because it is depending on the other two columns or three columns, okay? But every individual column is called as independent. Independent. Is that clear? It is independent column A. It is also independent column. Okay. Is that clear? So what is the difference between independent and dependent columns? Okay. So this is dependent column. Output is these two are independent columns. Okay. So when it comes to Bayes theorem again, naive Bayes, naive means it is assuming that the features, that means inputs, are all independent of each other. Okay, with respect to the class label. Despite this strong assumption, along with this, naive Bayes also has proven effectively in various real world applications, especially in text classification. Something like if you are going to deal spam classification, like spam, an email is a spam or ham, means not a spam. And on the sentiment analysis, positive, negative, neutral. In Amazon, you might have seen uh, the sentiment of the product. The product is good, product is not good, something like that. Especially these type of applications, naive Bayes is really popular because so many machine learning people or data scientists or researchers used naive Bayes to get the most appropriate results. Okay, it doesn't mean that it cannot useful for other type of applications. Of course we can use it. It basically assuming naive means um, all the features, input features are independent and with respect to the class label. Class label is always considered as output label or else a dependent column. There are many names we can call it. Target variable we call sometimes. Okay. See the Bayes theorem. Now we have to understand. Now I hope you got the naive means. Now Bayes. Bayes stands for Bayes theorem. Bayes theorem means if you see the formulation, it is something like probability of A given B. That is how we have to call it. Probability of A when already B has given to you is equal to probability of B given A into probability of A divided by probability of B. This is what the formulation of Bayes theorem. Okay. Where probability of A given B is also called as posterior probability. If you type in posterior probability in Google, you will get the complete statistics. Posterior probability. Okay. So especially in Wikipedia, So a lot of information is there. Is a type of conditional probability. Okay, you can see it here. We already discussed about this graph. Okay, standard normal distribution and prior probability, and a lot of information is being there with derivation and examples, calculation. Okay, but all the things now we are not going to like cover directly. We can say that what is this posterior probability, how to identify it is a posterior or not. I will give you a good example. I have that. And then probability of B given A, it is a likelihood. Okay, it is the likelihood. That means also I will explain why probability of A given B is posterior and probability of B given A is likelihood. I will explain you with a small example and explanation. And probability of A, you know that probability of A is simply, it is a uh, P of A is a prior probability, that is probability of A, initial probability. Probability of B means marginal probability. So we will discuss about a problem statement so that you will understand all these terms easily. Okay, naive Bayes assumption I already told. Just again I am giving. Naive stands for every column comes up with an assumption conditionally independent with respect to the given. This simplifies that computation of the likelihood as the product of individual probabilities of each feature. While this assumption is rarely true in real world scenarios, but classifier often performs surprisingly well. Okay, posterior probability, how to understand this one is probability of A given B means, example is, for example, if we want to classify an email as a spam or not, okay, entire email content, we wanted to find, entire email, we wanted to figure it out whether it is a email or not. Sorry, spam or not email or not, spam or not. We have an email, okay, we have an email. I wanted to classify whether it is spam or not. Okay, so let me show you emails. So these are all emails. If you can see, these are all emails. So for example, there is an email. I wanted to know, figure it out whether it is a spam or not. Okay, so this is what email content, and spam or not, these are two classes we have. Got it? So checking we are spam. You can also check for not spam, entire email content. But when it comes to likelihood, this is what is example is, if a word free appears in an email, then this is a likelihood. That means don't confuse. Of course, this concept is been confusing. Naive Bayes is actually confusing, but if you read it two times, then only it will really easy to understand. Uh, for example, in this email, in this email, if there is any free word, Control F and search free. Okay, there are two things are free, one and two. Got it? There are free is a word which is available, and here likelihood is we will identify, okay, according to the data set we will identify that most of the spam mails are having a word called free. Got it? Most of the spam mails are having a word called free. So that is what we are figuring out. Free inside a spam, that is what likelihood can be happen. Okay. And posterior probability is something like we are finding out a spam out of entire email content. If I pass this email to my algorithm, I wanted to know the probability whether it is spam or not. That is what, that is what, you know, posterior probability. And when it comes to the likelihood, okay, so a free is a word which is available, which is there in the email or not, we will check for. Okay, so that is what likelihood. Is my point clear? Posterior probability and likelihood probability, is it clear? Is this clear? Can I get a quick confirmation?
Yes, yes, sure.
Okay, very good. Very good. Okay, so now understand this example. So prior probability means we already know. Prior means we already know according to the data set what is the spam. There are 30% of the mails, whatever in the data set what we got, 30% of the emails are spam, 70% of the emails are not spam. Remember this. 30% are spam. Let me take paint. to explain. So according to the data set, 30% is what spam. Okay, 30% are spam. That means 70% are not spam, right? Obviously, 70% are not spam. That we are checking for a spam, correct? So that is why the probability of A is nothing but 30 divided by 100. Okay, 0.3. If you are checking for not spam, that is what you will get a probability of A. But we are now checking whether an email is a spam or not. So that is why probability of A is 0.3. Okay, then we are again checking a likelihood. We have a likelihood. That means most of the success factor, most of the spam mails is having a word free. How many spam mails we have? 30% of the mails are spam. Out of these 30 mails, there is a common term which we find out. That is what? Free. What is that probability? That is 80. That means 0.8. Got it? That is 80 percentage. 80 by 100 will give you 0.8. We have probability like of likelihood. Got it? Where free is a common term which I found out in 80% of the spam mails. Okay, that is what probability of free given spam. Okay, and we know probability of A already. 30% is 0.3. And what is the probability of then free? Meaning probability of a term free which exists in the entire 100% of the data set. 100%. Now we have 30% spam, 70% not spam. But if you club, there are 100% of the mails. I mean, all mails. What is the probability which I am having free as a word? Okay. So that is what the probability here given. That is 0.4. Means 40%. 40 by 100 will give you 0.4. Now understand the scenario. Probability of A is nothing but out of 100%, how many spam mails are there? Probability of free, which is there inside spam, that is 80%. In general, what is the probability of free as a word existing in the whole data set? Got it? So, for example, if I go ahead and search here, not in this particular mail, maybe here free. There are many words which are there. You can see there are many words in my email content which is having free. Okay. So I do also have a spam 4. In this spam, I am checking free. Okay. Maybe here, Control F, free. There is no term because nowadays spammers also very intelligent. They identify the algorithms. They are detecting very easily with this, with that. So they they are not including them. Got it? So earlier, this is the scenario. Okay. Using Bayes theorem, how we will identify the our required thing. Like our required thing means posterior probability spam in email content. That is what we wanted to figure it out, right? Whether the probability, whether it is a spam or not. Okay. So here you can see spam given free is equal to probability of, according to the formula, probability of B given A, likelihood. Likelihood is free given spam, that is 80%, into spam is 30%, divided by evidence. Evidence is P of B. So free is already we have, that is 0.4. So 0.6, 60%. The given mail, the given mail, if a mail is having, let us say, spam, sorry, free, if a word is having, if a word free is there in a mail, then what is the probability of spam? 60%. Is this point clear? Is this point clear?
Yes, Yashwant.
Okay.
Yeah.
So this is how, of course, it is confusing. Let me overall, let me again revise it quickly.
Okay.
Bayes theorem goes with this formulation. Probability of A given B is equal to probability of likelihood B by A, and probability of A, like this is prior probability divided by evidence. or marginal. So whenever you want to try this out, first of all, you have to figure it out the real thing that you are going to find out. The real thing that I'm going to find out is I wanted to know an email which is spam or not, especially if I have a word to check out. There is a parameter to check out. That is what free. If a email is having a free word, then what is the probability that email is going to be spam? That is what the use case in front of us. What is the probability again? What is the probability of an email which has a term called free likely to be a spam? Okay, then 60% is what we got. How we got? First of all, spam, free. There are two terms are there in the question itself. Then you have to understand, you have to focus about the free thing. Okay, you have to focus about free thing. Reverse this thing. Free in spam. That is what likelihood you got. 0.8. And particularly about spam. And particularly about free. And then club it in the formulation. You will get the result. Now is this clear? You just need to reverse this and you have to calculate this and you have to calculate that probability and then frame it in a formulation. Then you will got the actual result what you are looking out. And examples, types of classifiers means there are actually three types. One is Gaussian naive Bayes. It actually assumes that continuous features are there, follows a Gaussian. This is used for, continuous parameters. Okay. Continuous parameters means regression algorithms we use. Naive Bayes regressor. Okay. And here multinomial naive Bayes. This is designed for discrete data set. This is actually for discrete data set. And discrete means you have to understand it is for classification, particularly in text classification where features represent words or word count or frequency. Then multinomial naive Bayes is good. Bernoulli's naive Bayes suitable for binary. Got it? If we are dealing with binary or a Boolean features means yes or no, something like that, true or false, yes or no, or binary, then it is good. We can go for Bernoulli's naive Bayes. Okay. Got it? Then multinomial Bernoullis. We have two types can be used for discrete data. And Gaussian naive Bayes is also called as naive Bayes regressor. Naive Bayes regressor, if you type NAIV naive Bayes, scikit-learn, sklearn. Let me show you those things. Naive Bayes. Yeah. This is the formulation. You can see the derivations of how we got all those things. And then this is what the Gaussian formula. And here this is the way how you can use Gaussian naive Bayes. Just now we discussed, right? Gaussian naive Bayes. This is the way how to use. Here you can see Gaussian naive Bayes. So you can call that function and you can fit it x-train and y-train, and then you can predict the x test. You will get all those things. But it is suitable for continuous variables. Okay, and then multinomial naive Bayes, that is what we discussed just now. And then complement naive Bayes, sometimes also called as Bernoullis. Yeah, Bernoullis is another one. Another one is complement naive Bayes. Complement means in mathematics, you know, right? Complement functions are there. Then Bernoullis naive Bayes is there. Categorical naive Bayes is there. But these three are most commonly and widely used. And anyway, in mathematics, you know, one scientist will define one thing and another scientist or researcher will come and say that that model is really good, saves times and all. But you can focus on to the most common things, multinomial and Gaussian and Bernoullis, most common. And categorical is also fine. Categorical naive Bayes. Okay, out of the core naive Bayes model fitting. You can go through this documentation and understand. If there is anything stucking you, please let me know while you are going through the concepts. Okay. Now we will see that one more concept, naive Bayes classifier in machine learning, sklearn. So this is what the naive Bayes, and if you see Bernoulli's naive Bayes and click. So Bernoulli navibase is the function we have to use, and then we can simply use the same code, and instead of x and y, we have to use our x train and y train to get the algorithm results, and then we can predict our data so that we can see. That is why code is really easy. We can directly take from the resource, either from library or from community page, wherever we get. And what extra thing you have to do is you have to understand these internal things. Okay, what exactly is X? This will really help you. Okay, for example, here you can see these are the parameters that this algorithm can expect from user. If you are not passing something like alpha, if you are not passing while calling, by default it will take as 1.0. Force alpha will will be true. Binary size, binarize, sorry, will take as 0.0. Fit prior, by default it will take as true. Class prior, it will take as none. But if you can alter those, if you know that what exactly these are, you can alter them and you can try the different type of outputs. For example, alpha is always a floating value. By default it will be 1, and if it is set 0, then force alpha to be true for no smoothing. This is actually an adaptive feature, Laplace or Lidstone smoothing it is. And if you don't understand this thing, obviously you will not understand by looking at just this, and you can directly go ahead and search it here. You will get adaptive smoothing. Okay, or this is good actually, the analytical vidya content on this particular improve how to improve the nav based text classifier using the Laplace smoothing. Because in real time, why it is important to go through and everything is, in real time everyone can build an algorithm, but very few can come up with most appropriate results. How to get those most appropriate results means, if you really know the every parameter which is there inside the library and understand that, then you would know that when whether to alter them or else to keep it as it is and then try it out. For example, Laplace smoothing is actually used for test classifications. Okay, if we use the Laplace transformation according to this documentation, they are saying that results are really good. Okay, so the same probability we used, and like an example also it is clearly mentioned. Okay, positive, I wanted to check the probability of a positive in a review. In a review, I wanted to check a positive one. Then ignore the term X. So, like these examples, you can go through. Now it will take most of the time. We don't have such time, but you can go through what exactly Laplace transformation to solve the problem of zero probability, especially when a query point contains new observation which is not yet seen in the training data. While calculating the probabilities, then this concept was introduced. The idea actually behind is to ensure our posterior probabilities are never been zero. You got my point? We are assuming that these are never been zero. That is why we add 1 to the numerator and then we add k to the denominator, n to the numerator, 1 to the numerator, and k to the denominator. In any case, we don't have a particular ingredient in our training data. Okay, that is why. What is an idea behind Laplace transform, Laplace smoothing? You just go through, and so that you will understand whether it is really have to alter when we are using that as an algorithm. Got it? So in this way you learn. Now onwards, even with linear regression also, if you are referring to linear regression, a scalar, okay. So you understand what is this fit intercept is equal to true, copy x is equal to true, n jobs is equal to none, positive is equal to 4. There are only 4 parameters are there in with linear regression. Fit intercept is something like whether to calculate the intercept for this model or not. Sometimes it is true means yes, we need y is equal to mx plus c is required. So that why fit intercept is equal to true. If we don't want, then it will not calculate intercept. Okay, so no intercept will be used in calculation. That is, data is expected to be centered. All the data is in center only. So sometimes your graph, you know, the data can be like this. The data points are not there. So then intercept is not required. Correct? So you have to identify that whether it is true or not. So copy X simply. If it is true, X is will be copied. Else it will be it may overwritten. By default, it is true. It is saved as a copied data. Otherwise, what will happen is if we make it as a false, it may overwrite. N jobs means number of jobs to do it for computation. By default, it is none. We did not mention. But if you really want, then you can mention that how many jobs, how many times computation. I mean, number of jobs to use the for the computation. Okay, and then positive is equal to by default false. So if we set to true, then forces the coefficients to be positive. Means if we know that slopes are there, right? Beta 1, beta 2, beta 3. If you want them to be positive, then you can enable this function. But in reality, yes, maybe positive, maybe negative, right? But if you forcing them to the positive, then positive coefficients only you are looking out, then positive will become true. This is the way you can learn what are the parameters. Two things you have to understand in every algorithm: parameters first, and then attributes next. Attributes means what things you can fetch as an output out of that model. For example, yesterday we saw coefficient underscore means you will get all the coefficients beta 1, beta 2, beta 3, all the such thing. Rank, you will get the rank also, rank of the matrix. Okay, singular, array of the shape. Intercept, n features, how many features we used. This is also one good feature. Yesterday I missed it. Anyway, you can use that now. How many input features we tested on this algorithm? That is what n features underscore in. Okay, and don't forget to look at these things. These things will help you. Once you complete this concept, then what is an immediate concept to look out? Okay, in this way you can start learning. Okay, with an example, you can see in examples. Okay, where what is X, what is Y, sample weight, what is that? A clear example is there, and then some metadata routing is there, user guide. You can slowly ignore these things, but the up to here it is very important. Slowly you can also focus on these things also. Okay, so everything is important in complete document. It is important anyway. It will help you to see some gallery examples. Means next concepts. What is the next concept that you want to? Logistic function. This is also covered. Logistic function, how it is work. Yesterday we discussed sigmoid, yes, in between 0 0.5 and greater than. Yesterday we discussed the same concept. Okay, how exactly it uses and all. Gallery means it is a coding example. The other is scikit-learn developer only. Okay, it is having with license. Okay, so from now onwards you can look out all these things. So anyway, logistic regression covered, and now we are learning about Navibase. So again, classification, sklearn, supervised, we will get. Inside supervised, we can go and click the naive base. Naive base, multinomial and all. Instead, directly go to the Gaussian naive base. No, no, sorry. Bernoullis or multinomial. Any one of these two things we will use. Okay, today. Fine. Um, okay. So now we are using this as a data set, forecasting the car quality. So I will take the data set, and I mean I already downloaded the data set. This is the file. Sorry, this is the Kaggle thing I'm referring to solve in front of you the real. I mean one problem statement. Okay. Let me upload the data set. The data set I have is US batch. Car names no. Car. This is what the data file. Car dot data. Okay. So first of all, importing the libraries. Importing the libraries is what very important. You know already what all basic libraries. Import numpy as np, import pandas as pd, import matplotlib dot pyplot splt, import seaborn as SNS. Sorry. Yeah. Array. It might be in urgent, so 1 second, please allow me. సాయి క్లాస్లో ఉన్నారా? ఎక్కడున్నావు? సలార్కి వెళ్ళవేంటి? హలో, ఓకే, సారీ. Okay, so these are the basic libraries we just import. So let me write this. Once you did, then it is time to read the data set. Read underscore data files also can read underscore CSV. Sometimes it works. You can have a look. Data.head. Got it? So we got the data sets. But here you can see V high 2, 2.1, small, low, inaccuracy. These are not seems like the column names, right? So this seems like the values only. In that case, in reading CSV also, we have to add one more point, index. Index is equal to false. No, it is actually with Excel. Index is equal to false is available in Excel, not with CSV. Array. This Colab is not allowing the data.file. See, today, what is the thing is this data file. This is a data file. Okay. So, data file reading with pandas. Let me search. With the help of CSV, I can do anyway. No, read underscore CSV is the what? No problem. Let me deal this. With CSV only we can do. But here there is one more option will be there. To forget about the let me check. Header. Okay, here we have to use header. Okay, header is equal to 1. Header is equal to 0 if you type. That means the 0th one can be act as a column, but here these are not the column names, right? Then how to deal this means we can specify column names. Column names anyway given here. What are the column names that we have? Okay. So what are the column names that we have here? Anyway, they have given. We will get the data set from here also, I guess. Cars.csv. Mcars. Let me see if that data set is have columns. No, this is some different data. This data set I have dealt it error last time. Okay, very good. This is also good data set. Okay, it will have the gear function, carbon, all such things. Yes. Okay, no problem. How to deal this thing is let me tell you one more new concept. Here, the column names anyway, if you observe in our zip file, they provided very clearly car.names. Okay, you can see it here in notepad. If I type here, you can see the creator, the title, who created that thing and all. And here the names actually they have given. Okay, here we can take this. First is buying. These are the values. Okay, buying, and there are known missing values are there, and inaccuracy they are also given the class distributions. And here you can read the relevant information and all everything in real time. Also, this is the same thing. Okay, this is the same thing. So you will also be given, along with the data set, the information of the data set also you will be given. Okay, you will be given the information of the data set also same like way. For example, here it is given the same thing I am considering. Okay. Okay, first thing is buying, right? So I will add those things. Columns is equal to, I will create a list, buying, first thing. Second thing is, buying is V high and something like that. Yeah, it is making sense. Second thing is maintenance. Third thing is doors, doors. Fourth thing is persons, persons. Fifth thing is luggage boot, luggage boot. And sixth thing is lastly is safety. Okay. So these are the columns, right? So then how we can we replace these columns with our columns? Then data dot columns is equal to, there is a columns at attribute. Now you can alter this one. Then six are okay. How many are there here? One, two, three, four, five, six, seven are there. Last one is inaccurate. Something is there. That is what we missed. Let me go ahead. Along this safety, there is one more variable actually we missed. Car price is there, buying is there, maintenance is there, tech is there, comfort, doors, luggage boot, attribute values, class, exactly. Last one is called class. Okay, along with these things, last one is class. Safety, then class, class. That is why we got an error. Now we see the data dot head now. Yes, now we got the right things. Buying, maintenance, doors, persons, luggage boot, safety, and class. We wanted to predict the class, right? We have to predict the class. Okay, fine. So after this data set calling, now what actually we have to do in general is data dot is now, or else info is very good to go as a second function. So that you will get total, there are how many column rows? 17, 27 rows. 7 columns are there. So this is an object. Buying is an object. Cross check. Yes, it is an object. Object means string data. But if you see the doors, actually it is written in the numerical, but here it is also saying an object. That means something is there to deal. And the persons, if you see here, it is seeing as a number, but it is saying as an object. Small, these are all okay objects, fine. But these two columns, why they are objects? You identify. How to identify? Then you have to call that particular value which you wanted to treat. For example, doors, and check dot value underscore count. So remember these functions, okay? Value underscore counts will give you all the discrete values and their count of that particular column. Here I can see doors, 3 doors, 432, 432, 432, and 431. So it is very nicely arranged. The data set with 2, 4, 3, and 5 more is also there. This is the text. Due to this reason, the entire column is text or object. Is that clear why it has been test? Similarly, I wanted to know information about remaining column, which I also wanted to further check. What is what persons? Persons, persons. Here also more is a word is there. That is the reason why I got uh, you know uh, as a category. That is why we are getting these as an objects, though they are numbers in head. Got it? How to identify and check. If you feel that these are number, but we got object. If you feel you want to convert to back to the number, of course, here we have 5 more. We cannot convert this 5 more to a suitable number. Instead, there is something like 5 only. But you find that these are actually integers, but in our data set, if they are storing as a string, then how to deal is you can convert that to integer. You have to convert that particular columns to integer back. Then only the data is in pure way. Pure way means what exact the expected, and you can cross check whether it is like expected or not. But expected is integer, but for example, the reality is object. Then you can convert back to the integer. How to convert back? That is a task to you. Okay, simple. It is simple. We can take that int of data of, okay, anything, something like here persons. Of course, I cannot convert it because there is a string involved. I will get an error. If I have 3, 4, a number in a string, that can be converted back to the string, back to the integer. For example, a is equal to 5. Then I want to convert to int of a. If you give, then it will give me the integer back from string to integer. But here, if I say more, you will get an error. Got it? That is why I cannot convert it now. But that is the way how to convert the entire column to an integer and replace it with the current value. Okay, fine. You know, and you also figure it out. Okay, fine. And you also have to know whether the data, like how many classes that we are going to define. How many classes? That means data dot class. If you go and then type value underscore count. Yeah. Then there are 4 classes you are going to predict. Any class it can belong to, either inaccuracy or accuracy, very good or very good. The data being, you can see inaccuracy points are more, accuracy is less. Out of all, good, very good is very less. Okay. So how to deal if I wanted to have all values are same? So here it is called unbalanced data. Unbalanced data. This is, if you want to have all columns as a balance, then there is a concept called sampling. Sampling. Sampling in unbalanced data. Sampling is a technique, upsampling and downsampling. You can go through sampling in feature engineering, feature engineering, okay, feature engineering in machine learning. So this is also a good step. Upsampling and downsampling, there are two things will be there. So upsampling means if you want to increase the data points, for example, 384 to 1209, then that is what upsampling. Otherwise, you want to decrease that 1209 to 384 or 69. That is what downsampling. Okay, you can use that such techniques to make the data set balance. Okay, those things you have to perform in final project. Okay, so those things you can utilize and perform. You can do research and then do a final project. Final project, I told, right? I will give you the final project right after machine learning course, because till then you have to do the case studies. Okay, so once you start doing case studies, then only you will understand. See, here I use the term called sampling. Likewise, there are many ways to do the feature engineering. Okay, feature engineering subject is not simple. To be frank, 1 month is also fine. Good amount of time we can cover only feature engineering, different categories into domain and all. But we don't have such time. So how will you get to know about all such things here? After, if you start going through the case studies, then only you will get to know. Okay, okay, fine. Once we get to know all the important things, then what is the next step? Next step is simply, we don't have any, first of all, no null values are there. You can see all are known null. If there are null values, then you have to treat them. Here luckily we don't have any null values, then no need to treat them separately. And then describe function is really important. Data dot describe. If you see, there is only buying, maintenance, doors, count, unique, top, and frequency. Okay, So count means total there are 1727 values are there. Unique, there are 4 unique values, 4 unique value, 4, and class as also having 4 unique values. Out of them, the highest mode. This is top means highest mode. Buying having high as mode. This is mode 3. Doors are 3 doors are more. 4 persons cars are more. Medium luggage boot is more. Medium safety. Inaccuracy. Inaccurate is what very much we have in our data set. Frequency also you can check how many values are dealing these all things. Fine. Once you get to know the describe also, then you can do this case study. What else this person is using? First he read the data set. Okay. Then we get to know about unique values. If you want to only unique values, then unique function will help. So there are 3 things actually. Data dot unique particular column. If you select any particular column, let me take luggage boot. Let us say, okay, luggage boot, and if you type unique, only unique, okay, then you will get what are the unique values which are there in particular column. Similarly, similar to this function, if you instead of unique, if I type n unique, I will get to know only count how many unique values are there. But instead, if I type this one, value underscore count, instead of unique or n unique, if I go ahead and use value underscore counts actually, not count, you will get both the things. One is unique values you will get, the count you will get, also you will get the frequency of each individual unique value. Got it? So these are 3 things quite commonly you been using. Here you can see there are here the next step as a feature engineering, this thing already we dealt. This thing here, the person is using, you know, which type of uh, encoding. Yesterday we talked about 3 types of encodings are there: one hot encoding, label encoding, target encoding. Can anybody identified which type this is? Come on.
One hot.
Why?
Um, I mean, it's not labeling, I think. So,
Okay. It is not label encoding for sure. Yes, you're right. So
yeah,
now the only chance is either one hot or target.
target, yeah.
So now what is this?
Mm,
Come on, try. Here, are we mentioning a
I
specific?
think it's target, yeah.
Exactly, very good. So
Yeah,
now
yeah,
we
yeah.
are targeting, and also we are making sure that the data type what we want as integer of,
Integer,
because
yeah.
sometimes it may go and type as 4.0. Right. That is why specifically we don't want to assume our model by default as a float. We wanted to especially mention as int. You will get the integer only. No need to explicitly mention this. But anyway, if you mention that, definitely you will get only integer, not any other data type. That is why this other specifically replaced like this. And here also you can see how he dealt according to the data, I mean, according to the data set and according to the domain, how he dealt the things are very high 4, high 3, according to the complexity, right? You can see. This is what I explained yesterday also. Drug A, drug B, drug C, and medium normal cholesterol. And here, if you observe this one, especially 5 more, okay, 5 more, he took only 5. Why not 6, 7, 8? Because doors. How many doors usually? Max doors of a car. Max doors of a car. Maximum doors, typically 3, 4, 5. That's it. 5 is the last number. That is why he typically consider 5. Okay. And when it comes to the persons, maximum 8. Right. Maximum 8 in any premium car or big car. I'm not talking about the super luxury car, customized cars. but in general. That is why he specifically used such way. So we will also use in the same way, or else we will use our own way. Our own way means you can specify all the columns specifically. For example, data dot head, if you search, we are having buying first of all. You can take buying as a dictionary, okay, and you can see how many unique values are there. Okay, first buying dot unique, you will get, okay, data of buying I have to, or else data dot buying is also works fine. V high is there, so same way, something like that you can give like this, V high, okay, colon 4, there are 4, there are 3, yeah, okay, something like this. Similarly, buying is completed. Data dot map, you can use map instead of this. Instead of, if you feel this is somewhat complex to understand, you can use simple map, because map is already I have covered in Python class. Okay. And similarly, if you want this also as one of your example, then you can consider this also. I will consider this data of maintain. This is also nothing wrong. I will consider luggage boot also, big mood, and all safety also, same functions. And accuracy also, we will consider these three same. Okay. And then when it comes to the doors, I want to specifically mention to integer. Okay. Same code, but say safety, instead of safety, I will go for doors, doors column, right? Here also doors column. Replace how many doors are there? Same function I use for doors. There are two string 2 with 2, and string 3 with 3, and string 4 with 4, and 5 more with 5. Because doors, we know simple logic, more than 5 mostly not possible. And then simply one more column, last column, that is uh, persons. Okay, 2 4 persons, persons. We can replace 2 with 2, 4 with 4, then more means 8. Okay, so now buying done, maintenance done. Okay, buying done, maintenance done, doors done, persons done, luggage boot, safety, class also done. Just run it. Okay, class is inaccuracy, accuracy. Something is there wrong in class. Just we will check it, cross check. CLE, aha, acha. CLE here, CLESS, I guess. This is what the wrong thing. No, CLESS class. Maybe the values are CLESS class. Here we can see 1, 2, 3 only now. Already it was converted. Class is already there. Why did not converted? Data dot class. Acha, buying now comes to nan. Okay, fine. Because did not get converted. Map and all. Buying. Class 1, 2, 3. Why? Where I have given? Something galat hai. luggage, boot. Let me do one thing. Runtime, restart session. Quickly I will run. Hmm. If you feel it is something wrong, then better always go from the beginning. Go from the beginning is good way. Quickly run. Okay. So now unique values instead of persons class is what we wanted to check. Unique. Yes. Now we got it correctly. Now data.head is right. Fine. So now why we are getting an error means here we used 2 to 3 different ways. Maybe overwritten has happened. That is the reason. Okay. What I will do is I will take the same considerations. Okay. So buying, maintenance, luggage, safety, and class. Instead of this class, I will use this one and I will cross check. Inaccuracy is there. Yes, I'm taking it as 1. Accuracy is there. That is what 2. Very good is 3. Sorry, good is 3. Very good is 4. That is what ascending order. Okay. Accurate, inaccurate, accurate, good, and very good. Okay. That is why the values are being 2. So let me run this one. Okay. Now all are run. But now if we check data.head. So now what we left with is doors and persons. Okay, these two things we can handle now in a different way. Okay, so persons dict I can consider. How many unique values are there? These are the unique values of persons, right? Same code I will use persons 2 with 2 comma. Uh, yeah, we got it. Great. So simply 2, 3. There is no term called 3, right? Then we will get an error. Yeah. If you go and check, yes, now we don't get any error. Data.head is correct. Now, similarly, instead of persons, what we have to do is uh, doors. Okay. So DOORS doors. Then we got like this doors. Do, sorry, doors dict is equal to yeah 2 3 cross check 2 3 4 5 more. So here it is saying 6. So now we got as more means here actually it is 4. Here maximum is 8. I forgot to change. I will rechange it and then uh, do. Now if we see data dot info, okay, every value now it is in int and float only. Okay, now it is actually float in persons. Why? Persons. Persons it took as a float, but no doors it took as integer only. So persons means something again wrong here. So we can take this one back persons. So because this happens because I will tell you maybe remaining already been into the numbers and then one value is affecting. That is why maybe in that case we can replace it back in the same way. That is why there are sometimes a lot of challenges been come. Now if you go ahead and check, still this column is not at all. We successfully changed. Okay. So you can do that. Okay. I'm leaving it to you because it will take time. Simple. Again, you have to run it from the beginning. Then this problem will get away. Because the data was overwritten. That is the problem. Okay. Okay. So now what will I do is I will not consider person column. Okay. So then data dot drop person persons, right? Persons comma axis is equal to 1 comma in place equal to true. Yeah. Now if I look at my data, I will write here as a command. Okay, you can follow that. So don't drop this column. Instead like um, okay, don't drop this column is you can get that like we should not drop this, and we have to solve that, fix that. Instead fix fix this column. Okay, fine. So these are the data points as of now. Now we can deal these things. Safety class. Okay, class is what we have wanted to predict. Okay, so once we done that feature engineering and all, now it is time to select the uh, feature selection, right? Select the features, features, features selection. So now x is equal to my data dot data. Simple. I will use. There are two ways. Yesterday I told you one way, and two ways also I explained. There are two ways to select. One way is simply you can use this function column, and then you can get it, and then you can select that and remove the one which you don't want to include in x. Okay. Then y simple it is data of class. These are my x and y. If you go ahead and check x dot head, all you got, and y dot head, your x values and your y values. Once you've done it with it, then come back here. Then here, let us observe what are the ways. So he used it this way. This is also good. You can drop the final, I mean, output column and mention the axis. So that you will get as x and y is other one. Then we have to use this particular library to do the training and testing splitting. Okay. Training and testing splitting. Here, 20% goes to testing and 80% goes to training. And random state, here he used one. We can use any random state. I already told about this. So one means same results. If I want to get the same results as of him, so I can use one only. 42 means I mean sizes and data shapes will get differ. Shape is not going to differ anyway. The values inside that thing randomly it will consider the rows. Okay, that means one itself. 42 you can try. Maybe two people are can try 42. Two people can try one. You can observe the difference between the random states. Randomly it will select. If you are this is simply it is a kind of a seed. You are fixing one seed. Okay. Once we complete that, then it is time to go for Gaussian building. Okay. So here they used uh, Gaussian Navibase. We can use Gaussian Navibase. It is for continuous actually, but it is not that we can only go for that and then use. And here this already import already done in the beginning itself. That's why we can go and use these import statements. Why he called datasets? Datasets is not required. Datasets is not required. So I will skip this one. Now you can check completed. Okay. So now once we completed the Gaussian thing, okay, then it is time to test with the accuracy. So it is the model building. Now how to check with the test. This is what the prediction thing. Three things are important in machine learning model when you're writing the code. The first thing is what is the exact model that you want to try, whether you have imported that particular model correctly or not. We are going to try with Gaussian Nav base. Yes, we imported. First step is clear. Second step is, are you following the fit function correctly? Fit function correctly and calling the model correctly. These two lines comes under step 2. Means creating the model and then fitting the model. Third step is getting the predicted values. These are the prediction values. Okay, these are the prediction values, but actual values, if you see, why test? These are the actual values. If you want to convert this into list, then you can use to underscore list. or 2 underscore array. Not like this. Of class, you can select class or dot class. Array, why it has been like this? Why test dot 2 underscore list? Yeah, 2 underscore list dot array. Actually, np dot array of 2 underscore list. You can use like np dot array like this. You can use. See, these are all original values. Originally it is 1, class 1. We got also class 1. Originally it is class 2, but machine is predicting as class 4. Originally it is 1 again, class 4. Fourth value, if you see, originally 1, and here sorry, fourth value, number 4. Yeah. Fourth value, it is originally 1. We also got 1. But it is fifth value, originally 2. Sorry, 4. Sorry, 1. But we got as 2. Likewise, you can compare how many values are correct or not. But it is very difficult, right, to count 1 and 1. So that is why these functions will help us to do accuracy. Accuracy is simply like that. Yesterday I told you, number of correctly predicted divided by total predictions. You can see 66 percentage. This is in percentage. You can see I calculated with 100. 66 percentage only correct values. Remaining 40%, I mean 40, so 36% is wrong. Okay, 36% is wrong. Here he got 71 because he also included the persons column, but we removed that column. Okay, and confusion matrix, yesterday I told you, right? Confusion matrix means true positive, true negative, all such things will be there. Okay, so this is what confusion matrix. The diagonal columns should be more. There are 4 classes are there. Out of 4 classes, this is what the true positive of class 1. Okay, so similarly true negatives will be there, and diagonal elements should always be more. That is what important thing. Okay, so here diagonal elements of class 2 and class 3 are less. If you see, class 2 having false assumptions. Okay, you can see it here. So that is why our accuracy is 66. If our diagonal elements are more, then our accuracy also will be higher. Once they calculate a confusion matrix, then step 5. One more. Now it is time to fine tune to get the higher accuracy. Anyway, this fine tuning I will cover after our machine learning models. At it, like it is a technique actually how to improve the accuracies, bias variance trade-off, all such things I will cover after machine learning algorithms explanation, because that is applicable to all machine learning models, not only single machine learning model. That is why I will explain that concept after machine learning algorithms, whatever we have to discuss. Here actually how he is improving, just have a look in 2 minutes. Simple, changing the hyperparameters. Okay, changing the hyperparameters and then trying. Then so from 71 to 81 it came. Okay, confusion matrix, then you can see all the diagonal elements are having higher when it compares to the remaining. Of course, it is still having 18 values, so that is why the accuracy is still things. Got it? So that is end. This is the way simply you can go through the functions and you can go through the different ways to do. Okay, and so that you will get to know many things. Naive base, simply you can type naive base. There are many naive base things are there, classifier in Python. Okay, you can relevance, you can see with respect to date or with respect to the relevance. Relevance means highest things will come first. 5 years ago, you can go ahead and check how exactly this author particularly solved this. Many things he included. You can learn the many things. There are 3 different things we already discussed. This is multinomial, binomial, spam classifications and all. So how he used, let us quickly check within 1 minute. So he used in a way like info, we used categories calculated. After that, missing value check, no missing value. Then this particular thing is having like these values. Then he used frequency distribution of each category. Instead of this, we already know one straight away function, right? Value underscore count. Instead of this type of iteration, he directly might have go for value underscore count. Definitely he will get the result. See, very one important point here I would like to cover. If you observe, our categories is having, our data set is having no null values. Our data set is having no null values. You can see there is no null value. But if you observe the categories which are there in every column, here one category is called question mark. That means those question marks are actually null value. Instead of null value, the data collectors or data surveyors in, you know, typed question mark instead of null. So you have to replace such question marks to either zero or null value and then treat them accordingly. You got it? So you have, that is the reason why it is very important function value underscore count. You will get to know what type of values are there. Sometimes it is not that you always have the null value. Sometimes you also have may have question mark, not known, something like that. But see, there are many question marks are there. Maybe these are null values then. Got it? So here unique values. See, question came. How he unique value underscore counts. See, he also used question mark is there. There are total how many question marks are there? These many question marks are there. So how to replace the question mark? Then null value. He replaced with null value. Now null values, the recent null values are like this. Here one more column is having question mark. Then again replaced with null value. So all such things got replaced. Then if they count the null value count, see, work earlier it is not having any null values, but now it is having these many null values. Then how exactly he actually solved? You can check that strategy. How actually he solved. Okay, he actually solved. He just simply dropped okay. He actually variable in. Okay, so d type is not equal to the string. Where he solved. Checking the neighbors. There are 6 numerical values. Okay. Explore problems within numerical value. I will explore the numerical value. Missing null values in numerical. Missing values in numerical. Declare features. So he did not clearly mention in what way he actually solved, but you can specify work class are there are containing missing values. The number of labels with a category is called cardinality. Then higher number of value variables within a variable is known as high cardinality. High cardinal may pose some serious problems in machine learning model. So I will check for high cardinality. Categories with highest labels. Okay, he checked. Simple. Then we will see that NATO country is something. I will check for cardinality of plain test split. Acha. He simply did not consider that thing and then see numerical means he only consider the numerical columns and then simply check the if there is any. See, he simply did not consider these null values first. Work class and occupation and see these columns he did not consider and then simply calculated the whether null values are there or not. No null values, then defined the x and y, then x train y train. Anyway, we know 70% he used for training, 30% for testing. Then feature engineering, what type of feature engineering he used? Simply categorical, and then which columns are actually categorical. That is what this particular thing will help you. Okay, these are the all columns are having categorical. Then he simply he is null mean. He consider the mean. Okay, mean of the value, and then he simply replaced the with the mean. Target encoding he used with mean. Okay, fill now null value he is filling with mode. Okay, he is filling with mode. You can see all the null values he is simply filling it with mode, and then finally he is coming with category encoding. Which encoding he is using? Let me check. One hot encoding he is using. For all such columns, he is using one hot encoding. Okay. And then training and testing columns. He also use robust classifier, robust scalar. This is also min max scalar. And also one more scalar standardization normalization we already discussed that. There is one more concept called robust scalar. You can explore what exactly this do. And then he used that. Okay. And then hex train, Y train, model training, Gaussian naive Bayes, again fitting, prediction, and then check for accuracy. 80% he got. Okay. And then training accuracy and testing accuracy, both he got. And check for overfitting and underfitting. I told, right? At the end, I will explain like what this strategy applicable to all the machine learning algorithms. That is why. Maybe I will see tomorrow. I will cover because two anyway we covered. Overfitting and underfitting he checked. There is no big overfitting. Yeah, there is no overfitting and underfitting because both accuracies are same. Okay, fine. Then he checked the null confusion matrix. That's it. Classification report, F1 score, calculated everything. Got it? This may help you. I will share it with you in the group. Okay.